Good morning, ladies and gentlemen. Welcome to the École des Ponts Paris Tech for this 18th Matinale des Ponts, dedicated to digital twins for infrastructure. We are thrilled to be hosting this conference as part of the ELISA InnoCore Innovation Talks and the Digital Twins Master Program, both co-funded by the European Commission. Over the next 90 minutes, our panelists will take you on a journey through digital twins and their impact on infrastructure. We encourage you to participate by asking your questions in the chat, and our experts will address them in the Q&A session starting at 9:15 to ensure that the discussion flows smoothly. Don't worry if you don't catch any detail. This conference will be recorded. It will be available on our website tomorrow. And plus we will sharing the best moments of the events through social media. So be sure to spread the word to your friends, colleagues, and partners. But now, without further ado, I will be starting our conference with the introduction of École des Ponts Paris Tech Director, Mr. Anthony Briand.
Ladies and gentlemen, it's my pleasure to welcome you to this conference on digital twins for sustainable infrastructures. We will explore the benefits and perhaps the pitfalls of digital twins for the infrastructure sector and for policymakers. We have to remind us that the market of digital twins will be growing from $7 billion in 2021 to an expected $100 billion in 2030, according to Fortune Business Insights. A large range of topics are at stake when considering this important subject, including the carbon impact of using digital twins, the needs of building and infrastructures industry, the challenge on training programs to equip engineers with digital skills, or European sovereignty issues in data and digital, to name a few. In March 2023, the IPCC published its last synthesis report on climate change issues, which highlighted the necessity to improve the maintenance of infrastructures. The report notes that climate change has not only caused adverse impacts on human health and livelihoods, but also on key infrastructures. Urban infrastructure, including transportation, water, sanitation, and energy systems, has been compromised by extreme and slow onset events, with resulting economic losses, disruption of services, and negative impacts on well-being. These findings underscore the importance of our discussion today and the urgent need for solutions that can help us address the challenges posed by climate change. Furthermore, we are facing a shortage of digital skills among engineers. As a leading school in France and globally renowned in civil engineering, École des Ponts Paris Tech has early identified this challenge within its mission as a strategic investment to cope with ecological transition issues. By the way, we have existing programs such as the Executive Master Building Information Modeling, the Executive Master Digital Building Design, and even the Building Platform, an experimental equipment designed on the expertise of our laboratories, which gathers researchers from various backgrounds around innovative projects and demonstrators. It is essential to address this challenge at the European level, which is why École des Ponts Paris Tech has chosen to launch an initiative for training engineers in digital twins and for launching a center of expertise in that field within the framework of ELISA European University, a European alliance in which École des Ponts Paris Tech is a founding member. Let me greet Fernando Garcia Molina, the project director of the Digital Twins for Complex Infrastructures European project at Universidad Politécnica de Madrid. This conference, the Matinale des Ponts, is part of a series of conferences whose objective is to provide industry leaders with the keys to adapting in a complex environment. The Matinale des Ponts are privileged moments for the promotion of knowledge, reflection, and the sharing of good practices between our researchers and business practitioners. I would like to warmly thank our 4 panelists, Baptiste Escoffier from Sanef Abertis, Guilhem Villemain from Alta Matrice and SNCF Réseau, and 2 of our researchers, Jérémy Bleyer from the Navier Laboratory and Vincent Lepetit from the Gaspard Monge Computer Science Laboratory. I would also like to give special thanks to Sofia Daguiar, the current executive director of ELISA, but also the former head of Innovation and Digital for the Digital Twin program of the railway system at SNCF Réseau. Thank you, dear Sofia, for your presence and your insights at our conference. And a final thank to our loyal moderator, Stéphane Lemansu. In conclusion, I hope this conference will provide you with valuable insights into the benefits of digital twins for sustainable infrastructure and public policies. I am confident that our discussions today will help us find innovative solutions to the challenges we face in the infrastructure sector, and I wish you a productive and enlightening conference. Thank you.
Thank you, Mr. Director. Good morning to all. Welcome to this morning session organized by École des Ponts. Today I have the pleasure to present this conference with Sofia Daguiar. Welcome, Sofia. Thank you for joining us.
Thank you so much, Stéphane, and
Our
the director.
Sorry. Our theme today, digital twins, will they enable Europe to move towards sustainable infrastructures. On the program, 3 parts to fully understand the ins and outs of this subject. But first, a brief presentation of our participants. Good morning and welcome. We start with you, Jérémy Bleyer. In 2 minutes, could you tell us more about your role and responsibilities?
Yes, sure. Hello, everyone. So I'm Jérémy Bleyer. I'm a researcher at Navier Laboratory, which is the mechanics laboratory from École des Ponts Paris Tech. I'm also associate professor at École des Ponts and part-time at École Polytechnique, in the mechanical engineering department. And currently I'm the scientific director of the master program in digital twins, which is developed in the inside the ELISA program. And so in terms of research, if I can speak about that, so I specialize into theoretical and computational mechanics of solids and structures, so mostly for civil engineering applications. And I'm interested in modeling the failure of structures, so including plasticity, fracture, etc. And I'm using optimization techniques coming from the mathematical community. So this kind of research can fall into the scope of digital twins, in the sense that we want to develop models which can accurately predict the behavior of structures and materials using computational tools. So that's the part in which I'm involved. But at Navier Laboratory, we also have colleagues working on different aspects which can fall into the scope of digital twins. So, for instance, we have colleagues like Gilles Forêt and his co-workers who try to estimate structural damage into different structures using vibratory tests, for instance. So this has been developed, for instance, in railroad track applications with developing intelligent sleepers for rail track to estimate the track level of damage and to optimize maintenance. So this has been done in collaboration with Eurotunnel and Sateba. And there's also currently a chair with SANEF Abertis, which is with a research program dedicated to non-destructive monitoring of external pre-stressed reinforced structures. So this is a thesis which is currently developed to estimate the level of corrosion inside pre-stressed structures using complex monitoring. So these are examples of research related to digital twins.
Thank you. Vincent Lepetit, it's your turn. In 2 minutes, could you tell us more about your role and responsibilities too?
Yeah, good morning. So I'm Vincent Lepetit. So I'm a researcher at ENPC at École des Ponts in the research team called Imagine, and we work on computer vision, and more precisely, so I specialized in 3D computer vision, where we try to capture the 3D geometry, the 3D structure of real scenes from images. The kind of techniques we develop could lead potentially to the development, to the automatic constructions of digital twins. So typically we work with deep learning, artificial intelligence techniques.
Thank you. We continue with you, Guillaume Villemain. Could you introduce your company, your activity in 2 minutes?
Yes, thank you, Stéphane. I'm very glad to be here today. So I'm Guillaume Villemain. I'm acting as a CTO of Altametris. Altametris, you might not know Altametris, but we are a subsidiary of SNCF Réseau. We were founded in 2017 with the idea that drones could bring a lot of information to allow a new way of doing maintenance on the railway infrastructures. And in the life of Altametris, we started to develop more and more algorithm to process all the data that could be acquired by these drones, and now we are focusing on developing algorithm that could help extract information from all the digitalization that could be realized with new engines that are running on the tracks today. And there's a big challenge in that. Because it's a lot of information, there's a lot of kilometers that need to be processed, and you have to come up with ways that do that efficiently.
Thank you. And finally, Baptiste Escoffier, we listen to you. Could you present your company and tell us about your missions in 2 minutes?
Thank you, Stéphane. Hello, everybody. I'm glad to be there too. So I'm Baptiste Escoffier. I'm the Chief Information Officer of SANEF Group. SANEF is one of the 3 major motorway company in France. So we are in charge of something like 1,800 kilometers of highways in France. So we have a lot of infrastructures to manage. And concerning myself, I'm in charge of all the softwares and technology and systems that are used on the highways. Everybody knows the tolling system, but it's not only the tolling system, but also the traffic management systems and all the softwares needed to manage the infrastructures and especially to manage the digital twins.
Thank you to all. And first, we dive into the first of 3 parts, our exchanges with these questions. What is a digital twin, and which applications and use cases? We start with you, Jérémy Blayer. Can you explain us what we're talking about when we talk about digital twins?
Yes, that's a really important question, because I think that currently there's not really a standard definition of what is a digital twin. You can find many of such definitions online, for instance, and depending on the use case, etc. So you might have different definitions. But if we try to give a general one, I would say that digital twin is a faithful representation of an object, a physical system. It can also be a system of systems for more complex industrial application. And so it's a digital representation, so in the form of a numerical model. But it should be clear that it's quite different from just a 3D visualization of the object. So it's not just a 3D point cloud. It's not either a physical simulation of the behavior of this object or system. I think the main characteristic of what makes a digital twin is the fact that it's constantly related to data taken from the real system. So there's a constant exchange of information between the real system and the digital one, with monitoring on the physical system, inspections, etc. And this data is used to improve the quality of the digital representation. And then we can use this numerical accurate model to make predictions, to take decisions, etc. on this digital twin.
Vincent Le Petit, what's your
Yeah, so that's I agree. So that's a very general term that can cover many different things and many different use cases. So for me, it's a capture. So a digital twin would be a capture of a real scene. So that can be a construction site, that can be a building, that can be a city, that could even be actually a human patient. So sometimes you also have a virtual reconstruction or representation of a patient for medical application. So that's something which is very, very general. So it's not just exactly the 3D geometry, but also what we call in computer vision the semantic of the. So what are the different parts of the real scene? So is it bricks? Is it tree? Is it roads? Not just the 3D geometry. And once you have that, you can imagine a lot of many different applications.
Thank you so much, Vincent, and thank you also, Jérémy. So I have underlined some of the keywords that you mentioned in your definition, and identify that in a way it is complex to define because it's not one technology for one purpose, but we could say that we have different layers. So the word representation was an important one from both definitions. Analysis, optimization can also be other layers of the system, and you also mentioned the question of semantic. So now I would like also, Guillaume, to hear from you. How would you describe digital twin? How can we go a bit further than the buzzword that we see a lot in the medias, and how can we explain and help our participants to understand better how can they project and use this kind of technology?
Yeah, that's a that's a big question, but I would agree with what has been told just before. Digital twin, you have the digital part, so you have to come up with something that's representative of what you are dealing with. So if it's railway infrastructure, you have to come up with a representation of all the components that would make a railway infrastructure. You have the idea of the level of detail. So maybe for some application you don't have to know all the details of all the specific component, but for some you need to go to that level of detail. So given the application, you might want to sum up what would be your digital twin in a very short way, and you have the idea that all the objects are somehow linked together within this digital twin, so you can't have an object without a relationship or function that would describe it in the best way. So the application of that would be that let's say if you want to know more about a specific measurement, or you want to be able to simulate a train running on the tracks, you will need to have some information on some elements. So the function would be, can the train go through my infrastructures? And you would use all the information within the digital twin to make that simulation. What's
so in a way, if I can summarize for the audience, your challenge is mostly on the representation and linking the objects and the functions of the different functions of your system in order to be able to follow the operation that you're handling in your network. Now to resonate a bit with your view from the railway perspective, maybe we could jump into Baptiste Escoffier from the motorway perspective. How would you define digital twins?
So, I mean, digital twins, it's a model. And a model is something that should be logical and useful. I mean, a model could be something very simple but very useful. For example, like the law of gravity for Newton. I mean, it's a very simple formula, but it's very useful in it's to make bridge, for example, or things like that. There is something else useful, of course, but it's a basis. It's a basic. I mean, it's very important to understand that because it will drive how we will do digital twins. We have to define the use case. We need to explore with the digital twins, and we can design the model concerning these use cases. I mean, it's very important to understand the finality of the digital twins. In case of the motorways, we need to know our infrastructures. It's very easy to understand the bridge when we are building it, but after many years and when we have many bridges, something like more than 1,000, it's very hard to know them, and it's mandatory because we need to maintain them to be sure that everything is okay with them. So we are now in a new pattern because all our infrastructures is more than 10, 20, 30, 40, 50 years old. And we are not in a building movement, but we are in a maintaining mood. So we need to maintain our infrastructures, and it is a very challenge. It's a very big challenge because we need to know them, to understand them, how the time is working on them. And so for that we need a model, we need datas, and it's what we call digital twins.
Thank you so much. I really appreciate the notion of balancing the needs with the correct level of representation, which was a word that was largely used in the first questions. So this, from my perspective, is really interesting. But at the same time, you define that need regarding the use cases that you are developing. Could you tell us a little bit more of your use cases in which you try to develop this notion of digital twin?
For example, we need to repair the roads, the pavement very often. If we understand more the pavement and how the vehicles on the pavement is working, we can define new strategy to replace it. And I mean, in a ecological world, it's very important to work on that, because if we can use our pavements 1, 2, or 3 years more, I mean, it's less energy at the end used to replace it, and less materials. So I mean, it's one of the many use cases that we are confronting, that we meet today, and the digital twins are very useful to understand that.
Thank you so much. Really interesting, the capacity of using the representation, the data, the capacity to analyze the system, to take better decisions, optimize our decisions, and link it also to further purposes that are the environmental preoccupations that we may have. I would jump directly to Guillaume to contrast these use cases and these examples from the railway management infrastructure perspective, how you would illustrate some of those use cases.
Oh, there's a lot of illustration. So
I'm sure.
I have to pick one, or maybe two. So we have maybe one is about security. So when you are running trains on rails, you need to be sure that there will be no incident. So you have to detect obstacles, right? So you have to do what's called gauging. So you have to make sure that there's nothing that would stop the train from running. So doing that, you need to have a very precise measurement of where the rails are exactly. So that's a very first instance when you need a lot of detail to be able to do that measurement. Another example would be you want to renew your track, so you need to to move or to remove or add ballast. And to do that, you need to know how much ballast you need to bring at some point to make your work, or how much ballast you need to remove. And in the past, you would bring a lot of ballast from where it is extracted, so it would cost a lot of energy to move all that ballast. And now with digital twin, you can measure where there's too much ballast, where there are less ballast, and you can just move the excedent of ballast from one place to another where it's needed. So that would be two main examples of application.
Thank you so much, Guillaume. Thank you, everyone, for the sharp definitions and some of these interesting illustrations. I have a question that is puzzling me, and I'm sure that the audience also has that question. How do we start? Is it a global, a top-down decision from the company to invest in such a digital strategy around digital twins, or it's more an opportunistic, would say, bottom-up approach that is pushed by some use cases in which we find an opportunity? How would you, Baptiste and Guillaume, address these questions in both your companies? The floor is yours. Guillaume, for example.
Okay, so I would say it's a little bit of both, because with digital twin you can have a lot of application in one system. So in the past you would have a department for ballast, a department for gauging, a department for catenaries, etc., etc., and each department would have its own information system, its own engine or stuff to make measurements and etc. And with digital twin you can move all of that in a single application. So it means less engines, less material to make measurement, because you can, focus everything on a single application. So it's also about saving money. So for saving money, it comes from from the top, and the idea is also that you can have from the bottom, because you have to think of how you would make or use this new system for this application. So it comes from people who knows how to do the work and the measurement, that they know how it works, and the top management doesn't know how it works, so they have to ask from people who is doing that, engineers on a daily basis.
Thank you so much, Guillaume. Baptiste, from your point of view, and also with the information system hat, because I think it's trickier from that side.
So one of the other use cases that we met is that we have to share with the public authorities some the state of our infrastructure. So it's a very important point because of the security of the people that are using our highway. So we have to measure it with a specified KPI. And specific KPIs, and so it's very complex these KPIs are very precise, and it's very complex to compute, and we need digital twins to do that. So it's one of the main use cases that we meet, and so it's top down from this KPI, and we need to give the information coming from all the assets of our infrastructures, pavement, basins, tolling systems, everything. Okay, so it's very complex, and we need a lot of data for that. But also it's something coming from the basis, because we need the information to work on for the maintenance, for example, the maintenance of the equipments, the maintenance of the infrastructures, the pavements, and things like that, in order to save money sometimes, in order to save materials, to save for ecological and environmental preoccupations. So I mean, the answer is both. It comes from the basis and from the top, and we met the basic and the top in the digital twins. Yeah.
Thank you so much. Really interesting. So I would say that in a way there's a constraint, a need, that in a way it's common to the company. That may be a growing, holding or really vast network of infrastructures, a need to report or having transparent information for a stakeholder, and connected to the impulse and from the business units that in a way manipulate and have the know-how of the business. This is more challenging, I think, but in the next questions I think we'll go through. Stéphane?
Jérémy, how do the digital twins represent a multi-sectoral innovation? It is a recent approach. In which sectors can they be found? Could you remind us the recent history of this?
Regarding the history of, so I think the word has been introduced in the early 2000s by a professor from University of Michigan in the manufacturing sector. So the idea was to better represent industrial processes, to build objects, etc. But in fact, the concept, I think we can trace it back to the early 60s with NASA, who first, so it was not a digital twin, but a physical twin of space shuttles and vessels that they built on the ground, and then with the development of computers, etc. They were really at the forefront of having a twin of what is happening in space to better react. So if you've seen Apollo movie, it's exactly like this idea to be able to test scenarios and to take decisions. And obviously, since then, there are some industries that have used and developed these concepts earlier than others. I think right now the aerospatial and aeronautics industry are really at the top level. The naval construction also, when you build a nuclear submarine, you can imagine that is extremely complex and that you want to have an accurate numerical model. Formula One also really always at the forefront of technology. So in this case, it's useful for both development, design, to test performance of the object. We've mentioned maintenance, which is, I think, a really important use case for infrastructures, but also for this kind of applications. And also an interesting one is virtual training using augmented reality, for instance. So you can, if you have a model of the submarine, you can train your teams to evacuate, etc., without the need to do it on the real infrastructure if it's already built. So you gain time, etc., for training. So we've mentioned also the manufacturing industry with automobile, with self-driving cars, etc. So here you have lots of sensors, cameras, etc., to take decisions and have a model of what's happening. It's a bit the same for the robotics industry, because you have sensors on robots, etc. So I think this digital twin is a key concept in Industry 4.0 to build more digitalization into the system. Vincent also spoke briefly about health. So you have digital twins of patient profiles depending on your way of living, etc., your biological parameters. And I think they also use it for organs, for complex surgery, again also for training purposes, to test the procedure before doing it live on the patient when it's complex. And then obviously what we are interested in is the domain of construction, infrastructure, urban planning, etc. So digital twin is a central concept of what we call smart cities, with a model of the city itself, of its population, the way buildings are built on the territory. And I think that there's a study which predicts that in 2025, so 2 years from now, there will be 500 cities which will develop a digital twin of their cities. So obviously these are big investments for cities, so it's mostly for metropolitan areas, etc. But so we see that infrastructure, so digital twins in infrastructure are, I think, an emergent technology, maybe more advanced inside some sectors, like managers of linear infrastructures, let's say, which are really big. So I think what has been said before is really important, is that it's a way to know your infrastructure. So the first one of the main use case I see is to collect information into a well-managed data system, etc., and not to have different databases which are not necessarily connected to each other. So I think this is a really important use case for these kind of applications. So now I think for other applications like a single building, you also have the concept of smart building. So trying to optimize the energetic performance of the building, for instance. So if you have light or temperature sensors inside the building, so you can and have a good model of how heat is distributed inside the building, trying to optimize heating inside or ventilation inside the building. So there are a lot of applications in such sectors.
Thank you so much. It's really interesting to see all the examples that you bring. But one thing that is common, it's still the need of innovation and research around that topic. And the potential of digital twins are enormously if we reach the step of knowing the infrastructures and being able to decide better to plan and optimize. So my question for Vincent would be the following. How you think these digital twin approach can be really a lever for innovating and for pushing and contributing to the green transitions?
Sorry, to the what?
Green transition, all the environmental issues. We were talking about the examples, for example, of the cities that will be transformed into and replicated into digital twins. How you think that this will contribute and the innovation and research behind it will contribute to this.
So in the case of a city, so if you know the material of your roads, where you have parks or trees, then you can simulate. So that's once you have this digital twin of the city, then you can start simulations of how the flow of cars are going to change or to move, or how the temperature is going to evolve with the climate, and then you can start planning how you can change your model. Once you have the simulation, that's something which is very convenient. You can try things on your digital twin instead of trying directly on the real city, on the real thing. You can try different solutions, different aspects, and then you can take a decision. So that's one of the general application of digital twin. So planning or monitoring, definitely.
Time for our second part. To exist, the digital twins need data, lots of data. So here is a question: how do we manage data? How do we collect, analyze, and process it in the context of the ecological transition?
So data, we were talking about representation, optimization. Data is at the heart of it, of course. So to better understand what's at stake here, what's the situation? What is already being applied, and which models are you using in your different fields? May they be research or the application field? So my first question would be for Guillaume around altimetries and your business, core of business. How is the data important? How do you use it? And which kind of models are you trying to develop around it to feed the digital twin approach, of course, in your field?
Yeah, I told it earlier. For the instance of ballast, when you want to remove or refill the ballast on the track, extracting the ballast is something that is very CO2 generating, because you have to carve all the rocks from carriers and bring it to the site where it needs to be refilled. So it's a lot of energy that's wasted when you can just pick the excedent from, let's say, 1 or 2 kilometers away from the site where you need to refill, because there's too much nearby. So it's a saving. We have also application on vegetation management, because vegetation is hazardous for the train circulation. But managing the vegetation is something that needs to be done wisely, and to do that wisely, you need data to be sure where you need to cut, where you need to manage, and how you need to manage the vegetation. So having more information and more ways to do more accurate actions, it means savings in energy you would waste otherwise doing things that are not maybe as accurate as it would be thanks to a digital twin that would give you insight and to tell you what should be the best action for maintaining your infrastructure.
If I know well, how do you capture that data? You have trains that are capturing this data constantly and that you treat her. Could you tell a bit of that? How you collect your data?
Yeah, there's different ways to acquire data. It's the beginning for the digital twin. So you can have trains that runs the tracks and while running acquire data. You know, there's a lot of trains running on the track. Maybe not today, but the other days. So all these trains could be equipped with more system. So and you can have also specific trains with more sensors, more systems that could acquire data and run the tracks. I mean, every day, and to cover all the infrastructures. So that trains running, you can have also information from the sky using planes or helicopters or even drones for small area you want to cover. You maybe in the near future you'll have some drone that can covers very long distances. So in the future you can also have drones that are totally autonomous and that can I mean more in a greener way than helicopters with electrical drones that could do all that acquisition. You can also have sources like people on foot, but that's not really the best way to acquire data, because as you know, the tracks are a place that are somehow dangerous. If you walk nearby, it's not really easy to go there. So yeah, mainly trains, and the idea is also to regroup, have less material, but material that can acquire more data. So the idea is also to do more with less. So it's something that it's an ongoing process in Réseau, and it's a great adventure, I would say.
And what's still left to be done ahead of you? You mentioned it briefly.
What's left to be done is to regroup every department, every engineer that could benefit from the data, and to say, okay, you were doing your job using some information that were collected with a specific system, and now you have another source of data that could be that digital twin. And you put more data in that digital twin, and you can do the same job, you can do the same analysis, you can do the same risk assessment with the digital twin, but it's regrouped in a single application. So you have to come up and to, I would say, you have to engage people to understand how their work can benefit from digital twins.
Thank you so much. I have the same question for you, Baptiste, because I think you're in similar contexts too. So from your point of view, what are the challenges around data, the innovations that you still need to push, and the challenges that you face, particularly in your responsibilities?
Obviously, data quality is strategic. So the value added of data doesn't exist if the data is not reliable. So the question is how to make the data reliable. Because the digital twins represent the reality, and the reality is not static. So we have to design something that is dynamic, and all the guys that are working on the real infrastructures that they make changes. Sometimes it's some maintenance, sometimes it's when they can replace some equipment and things like that. So we have to make them contributors of the digital twin. So we decided in SANEF to join the digital twins with the digital transformation of the companies. And we designed some new softwares for the different services that are working on infrastructures, and these softwares are very useful for them to manage their activities. And as they manage their activity, their work, they do that job. They contribute to the data of the digital twin. So at the end, everybody is working on the infrastructures, making changes. They are making changes on the real infrastructures, but also in the digital twins. And as they are using the data to work, they can correct the mistakes and the bugs and in the digital twins, and they can contribute to enrich the data. So we begin with a model that is quite simple, and we plug all the services on these softwares, combining the digital transformation of the company, and day after day we enrich the model by acquiring more information through the intervention and the activity of the guide. So it's global transformation, and now we have a digital twin that is reliable. We can trust on it, and we can use it for new use cases, like the study of how the infrastructure are aging, and it's very interesting. So
it's fantastic because you bring new notions here: availability of the data life cycle management, include the data as a new process, because before business units were handling their jobs and data was not part of the reality, and how it is important to bring those processes into the company as a whole strategy. That's why it's such an important also to merge the approaches of the strategical approach of digital twin and then the use cases. So thank you so much for bringing that. And I'll give the baton to Stéphane.
Question for Vincent. What are the data issues? What are the data challenges?
So yeah, so for me that's maybe the really main challenge. So the first thing is to collect the data. So we already talk about that. So in some cases, so that can be complicated. So if you have a very large scene, so that can be a city or the train, so the train system. In some cases, actually, it doesn't have to be very fancy. So if you want to have a digital twin of factory, just static cameras can do the trick, and that would be much easier to collect data. But it's not just a matter of, we already discussed that, so it's not just a matter of collecting the data. You have to transform the data into something that is useful, and that's really, I think, for me, that's really, at least in terms of the kind of things I do, that's really the core challenge, to transform these data, so these raw images captured by cameras or maybe other sensors, in fact, into something that is useful. So interpreting these data, that can be quite a lot of data, but it's not just a matter of volume. So really understanding what we are looking at into something useful. So in the case of I don't know, for the rail, so where are the vegetations close to the rain? What is the shape of a bridge? For this, you need to analyze the data, and for each field, you probably need different techniques. So these techniques can maybe be shared between different fields, but for each different field, you probably need to develop new techniques, new things to really to adapt to go to the point where it's the data you collected is useful, and that's still very challenging, in fact. So with what we have, we can already do things that are hopefully useful, but with time, I think we can do something much more and more useful.
Jeremy, what's your opinion? What are the data issues?
Yeah, I think the question of data is really central in this notion of digital twin. For me, one of the main difficulties is that data is extremely heterogeneous. So because you can acquire different types of data, if it's a time signal for an accelerometer on a bridge, for instance, or it can be images or point clouds, etc. So, as Vincent said, we need different algorithms to extract meaningful knowledge from this kind of data. It can also be operational data like frequentation of people or weather data, and in this sense, you can see that there are also challenges in making some data open. So there's the notion of fair data, which has to be findable, accessible, interoperable, and reusable. If you want to have a digital twin which relies on some external data for weather conditions or climate change, etc. So you need also to have interoperable components of one digital twin with other data sources. And what's also important is that data can be wrong because of experimental measurements, drift of sensors, and or error from human collection. Sometimes it can happen, etc. So you also need to have algorithms which are robust to errors, uncertainties, etc. So this is also a technical challenge. And also an important question for me is usually we say that digital twin, it relies on real-time data, so constantly being updated. And here, real-time, it really depends on the application, because you can imagine that for Formula One engine, you need by the second or maybe even smaller. But if you want to have information about traffic in a city, maybe it's by the minute or something like that. If you want to monitor the level of water levels in water tables underground, maybe it's by the week, or I don't know. So it really depends on the use case. And so for me, the main challenge is that this data, it really questions all the process inside the company. And I think, like Baptiste said, it's really important that there's a digital transformation inside the company to be able to tackle this question of data at all the levels, because there are some questions on acquisition, some questions on processing and analyzing the data, and at some point, I think the main goal of digital twin is to make data-informed decisions. So you need that data should be at the end reliable, and that you have confidence in your data to take important decisions.
Thank you so much, Jeremy. I've noted some keywords that interpelled me: interoperability, heterogeneous data, in a way also data management models. It's really interesting. And this, in a way, also what I see is we constantly need to be going up on the scale of the digital twin and down to the scale of the use case to understand what we are doing. The umbrella approach and the use, and understanding the need of the use case or the business unit that is around that. So this is really interesting. So I will go to Baptiste, and from your perspective of innovation, system management, what are the key challenges that SANEF is facing around data?
I mean, concerning our position, we don't forget that we need to know our assets. I mean, it's a very interesting. It's very important for us for different use cases. Okay, to give information for our public authorities, but also to understand how all the elements of our infrastructure are working together. I mean, it's very important to know that, because all the elements of the infrastructures have a function, and this function is operating with the other elements of the infrastructure. So, for example, for an environmental point of view, the collection of the waters, and especially the used waters with some pollutions, is something very important, and that works with pavement, with hydraulic infrastructures and basins, and we need to understand, and we need to know how does it works. The pavement is working with these hydraulic infrastructures and with this basin, in order to check the pollutions and things like that. So, I mean, today it's something that is explored, and it's very useful for us, and it's some innovation in our process management, more precision, more information to address these new use cases. I gave some minutes ago the another example about the replacement of the pavements and optimization on that. I mean, there is obviously some other use cases on repairing the bridge, because it's very more complex to repair a bridge than just destroying it and rebuilding it. So I mean all these new information can help us to optimize our main mission, and the optimization at the end, it's less energy.
Thank you. Perfectly clear. So in a way, we have here an important triangle: managing, operating, and dealing with the processes, balancing with economical stakes and also environmental stakes. So this brings us as the use of the digital twin as a potential and a really important approach to take the most of these three important aspects in managing infrastructures. Stefan.
And don't forget, if you are watching us on internet, you can send us your question for the end of this conference. We count on you. Third part of our conference: what is the role of the engineer and how should the profession evolve? As you have understood, the digital twins open up many new perspectives and will shake up our way of working. So what will be the future role of the engineer? How can we expect the profession to evolve in this context of digital transition? Sophia.
Thank you so much. So we know that this is important, as you said, and as our guests illustrated, digital twins bring a lot of opportunities. It also brings a new perspective for digital transformation of the different sectors, companies, and also impacting society. So École des Ponts has launched also with some partners at Elisa European University this new master. Jérémy, could you tell us a little bit of what is in stake here with this new program?
Yes, sure. So it's a program which has been funded by the European Digital Program for 4 years. So basically, we have 1 year to develop a master program for engineers, and then 3 years to deliver it. And at the same time, we will also develop a center of excellence which will try to create a network of academic industrial partners on these questions to gather best practice, foster new projects, and accelerate the development of startups. So the partners are members of ELISA, so we've mentioned UPM Madrid, École des Ponts, BME Budapest, Istanbul Technical University, and the University of Bucharest, with also 4 SMEs. So there are 3 companies in Spain, which are Noman, Tyrese AI, and Mainrail, and we also have Altametris, who is part of the project. So if I speak more about the master program, because it's related to this question. So when you look at the challenges that sometimes you see about digital twins, so we've mentioned maybe a lack of definition, standardization, etc. It's not always clear what is the proper use case, but one of the main issue which comes when you speak with people is the lack of training of engineers and even young ones on these digital questions, because as we've discussed, there are a lot of aspects which come into the development of digital twins, like what is data, how to analyze it, etc. So the goal of the program is really to train engineers of the construction, civil engineering, architecture, transportation, etc. So all these sectors related to infrastructures, to train them with information technology skills related to digital twins. So we will have some basic training in data science, programming, artificial intelligence, cloud computing, etc. And also in a second part, some courses more related to the application of digital twin technologies to this sector. So what are the general design, deployment, and use cases of digital twins, and then some specialization into transportation, smart cities, construction, infrastructure management, etc. And this will be also complemented with a conference cycle where we will invite some professionals, maybe from different industries. We've mentioned manufacturing, but it can be also nuclear engineering, etc. So the goal is to discuss what is the current use of digital twins in their sectors, and what are the best practice and the current challenges, so that the learners, they have a broad vision of digital twins in different sectors, and they can apply it on their own problematics. And then at the end there will be a capstone project, so a group of students who will work on a real case of digital twin with in partnership with an industrial partner, and that will be mentored by industrial mentors and academic ones, and they will apply the knowledge that they've seen in the courses.
Thank you so much, Jeremy. This is really the digital twin, huge example in which partnership and cooperation around companies, academia, and gathering different stakeholders is key to be able to address the potential and also the innovation challenges and the skill gaps that we may have around these topics that are really new. So thank you.
Vincent, Guilhem, Baptiste, what do you think of this initiative? How do you see the evolution of the different profession concerned?
So yeah, I was going to say something very similar to what Jimmy said. So so in terms of, we should probably put more emphasis now to data science, artificial intelligence. So that's which is something not necessarily natural for civil engineering, for example, but the importance of IT, but really specialized IT data science. So we mentioned that data capture, data analysis is the main challenge, and that's something. Yeah. So the future engineers need to understand. So it can be difficult to understand, to have a good intuition of what is possible with AI and what is still challenging. So they need to be trained for that. Maybe they are not going to develop directly the techniques. Maybe they will, but at least they need to understand that. They need to be aware of it. What is possible to do, what is easy to do, what is still challenging, and just to need to be aware of that at least.
Guilhem?
Yeah, I would also say something very similar, but I think what we need the most is some general engineering. So you have in the digital twin, as we said, you bring into the digital twin a lot of topics, and you can't have just a collection of experts. You need experts because you need it needs to work, but you need to have people that can make it real. So you need to have people that can apprehend all the main issues, all the main challenges, and to know what's doable, what's not doable, and to be able to understand all the topics of this very wide field, and you really you need to be taught into that, because it's something new, so new things needs to be learned too, and being able to think digital twin, you need to really cover all the fields, not as an expert, but general engineering, the key.
Baptiste, what do you think of
something similar? No, I'll try to say something different. First of all, I mean the environmental preoccupation is very good news for an engineer, because there is a proverb like my mother told me when I was young. What you don't have head, you need legs. But the contraposé of that is if you don't have legs, you need head. So I mean, less energy is more means at the end more intelligence. So digital twins is a very good opportunity to optimize, to be more clever in everything we do. I mean, it's not an opportunity; it's a mean. It's a mean to be more clever, and we will need to be more clever and to prepare everything we do, all informations. I have a small anecdote in my head. When I was a bit younger, I work on a civil engineering use case. So we have to put a train on a bridge that has been made in at the end of the 19th century, and I was very to do that. You have to take all the informations that have been gathered by the engineer of the last century. So I mean, it was so rich. I have so much information coming from the guys that has worked with a there was no computers, there was only papers, but everything was written, and all was so precise. And I wonder why so much precision with no means. It was so impressive. So, but it was mandatory, because as the energy was so poor in the 19th century, they need to think of how to do the stuff, how to prepare the construction of the bridge, the build of the bridge, and so he really needs to collect all this information and be the more clever as they can. So I mean, today we are in the same way. We will need to be more clever and to collect more information to prepare more our intervention, our building infrastructure. And the second point is that all the infrastructures that we have inherited have been made by guys that are retired today. They're lucky guys. I'm not sure that everybody will be so lucky. We'll see. But they are not there to explain how it works. So we have a specific mission, is to collect this information, be sure that all this information are reliable and are shared with other guys to ensure that the infrastructures will live longer than the guys that are managing there today.
It's a good perspective. Thank you so much. And you bring me also to my last question before closing this topic, is in a way the perspectives. You mentioned it a lot in the point you made. How do you see the developments and the importance of digital twins in the near future? This is a quick round of comments to close up. Before that, we go to the public questions. Who would like to take the floor first? Jeremy, go ahead. I see.
Okay. So yeah, I think there's a huge potential that we've seen. For me, there's also a risk. What's clear is that to invest in digital twin technology, I think it has some cost, from training people, recruiting new people, setting up computational infrastructure, acquiring data, etc. So for me, it's if you don't have the proper vision of what would be the use case, and if you don't invest and be consistent in time with this technology, you might have the risk of not exploiting them to their full capacity. And I think that if we speak about maintenance of infrastructure, for this to be successful, I really think that we should think the virtual twin as a component of the infrastructure as the physical one, and it means that we need to maintain it also, to have a proper management of this digital twin, because if it's not properly managed and updated, etc., you will lose all its predictive power at the end. So I think that it will, in some sense, probably create new jobs like digital twin manager or something like that. I don't know exactly, but clearly there are some opportunities for this. And I really think with the global question of sustainable infrastructures is really key to make progress in this sense. We often speak, for instance, in the construction industry of reuse of materials. So this is an important aspect. It would be very good if we could reuse the construction materials. But I think today it's really difficult because we don't know precisely the buildings, how they have been designed, how they have lived during their lives. So I think that digital twin, they can help monitor a building over its full life, keep track on how it has been built and changed during its use, and knowing exactly at the end of its life what is inside the walls, etc. And also it should have been designed with thinking before that at some point it could be dismantled and we could reuse the material. So it starts now, but we need to keep track of this with this digital twins. So yeah, I think it's really a good opportunity to move towards this kind of important aspects.
Thank you. By your examples, the future is still wide. Guillaume, how do you see the future?
I couldn't agree more with Jeremy because the point we are today is more about how we will do that. So it's more about how we can think of a digital twin in a new use case and how it could be used in a lot of application. We saw in the railway industry how we could use it, and I hope we will continue to use it and have more and more use cases. But in the future, you'll have to maintain that, and it's really a great point you made, Jeremy. And we in the IT we are speaking of architects. So you have to imagine the architecture of digital twins, but tomorrow you'll have to maintain that, and the architectures. You think of buildings when you think architect. You think buildings. Buildings when you're renewing. You think there's a notion of destroying the old buildings and building new ones, but I prefer the term of gardening, because gardening, you plant a seed, so the seed is planted now, it will grow, and you'll have to maintain the digital twin garden, and we need digital twin gardeners for the future, for a greener future, right? So great.
Thank you. Vincent?
Yeah, so it's probably a long-term things, but in fact, there are already many things that we can do, and that can be actually a continuous development. So from images, we can already get the 3D geometry of a building, maybe the 3D size. So we say that a digital twin is not just the 3D geometry, but in fact the 3D geometry can already be pretty useful. So that's already a way to get started with digital twins, I guess. With images, we can also get the amount of vegetation, for example. So that's there are many little things, so maybe not little, but things that we can already do that maybe not exactly digital twin, but on the way of getting a larger or a real digital twin that can already pretty useful if you are clever about your applications. So that would be a continuous development.
Thank you so much. Baptiste, a last sentence.
I'm very happy to see that the engineering school are evolving in this way, because we need some civil engineering that are able to design sustainable infrastructures that are easy to repair, easy to maintain, easy to know. And it's a really good opportunity for this new engineer, and I'm very happy to see that the school are adapting to that. Yes, in the IT, in fact, modeling is something very common. There is some standard on that, like UML or something like that, and we always model the reality. These capabilities of modelization are really mandatory now. For civil engineering too. So we have to meet all the different universe, classic engineering and IT and information system engineering. So and that's how we will do digital twins and sustainable infrastructures and sustainable world.
Thank you for these exchanges. Time for questions now. We have almost about
6 minutes.
6 minutes. First question, Sophia.
So I think this question will be mostly to Jeremy, to Baptiste, sorry. How are dealt security issues of these data? Is there a big risk of hijacking systems?
Yes, cybersecurity is is a central problem, and I mean.
Sorry for pointing you.
I mean, the question was about cybersecurity, but maybe about security, physical security too. But about cybersecurity, it's a central question because, but not only for digital twins, but also for the rest of the IT. And I mean, we're working hard on that, and we are better and better. Of course, it's critical for physical infrastructures at the end because if we use the data to take decisions, we need to trust the data. We have seen that, and to trust the data, we need to be sure that all the data have been not hacked by some hackers. I mean, it's a central problem, a central question, but I'm quite confident about this question today.
Does someone else want to react to this question? No, it's a difficult one. Cybersecurity.
Second question.
So the second question is a bit more global. Is there a right methodology for setting up a digital twin in a company? What would be the first major steps? So maybe Guillaume, you want to start?
Right. Another difficult one. I would say it depends. It's maybe not the answer you what was imagined, but you need to design first. So I would say having a board and a pen and building box and making a relation between these boxes is a nice place to start. But there's a lot of tools that can help designing what would be a system. Baptiste, you told you told about ULM. It's a way of designing softwares. But yeah, the idea is design. You have to think what are the main functionality of your system. What are the main bricks that needs to that are interacting, and then the technology would come after, because you first need to know what you want to do, what you need to represent, and then you can pick the technology that is the most suitable for that.
Thank you so much.
If I can I think that technology is here, so we have the technological tools to do what we would like to do. Obviously, there are still ongoing research on efficient algorithms, etc. But I think that a good way to start is to really focus on the use case and to be really confident about what will be the purpose of your digital twin, and rather than building a very complex system and a monolithic one, which is at the end very hard to maintain, etc., it's better to build specific blocks with specific objectives and try to focus on making them easily interoperable. I think that's a good way to start. Start small and then grow on top, but with building blocks rather than a monolithic system.
Thank you. Perfect. Baptiste?
Yeah, well, I really agree, because in IT technology we speak about development. We use some word of the life. When you see how a child is growing. It's not a man in just one time. It's progressive. It's exactly the same in designing software. So we have to start. You have to start small, find a precise use case, simple and variable, and design something that is near the reality, and that will design something simple that which will grow. Use case after use case. It's a good approach.
Just 1 minute for the third question.
So we have here an interesting question, and for all of you, the fourth. What potential do you see in having a digital twin of an university?
In 1 minute, please. Jeremy?
So I didn't think about that. No, obviously, I think there are questions related to, a university depending on the size of the university. But if we think about big ones, it's like the level of neighborhood in a city, I think. So you have questions about mobility, etc. And there's also an important aspect, I think, for cities, which is the tourism. Try to showcase this nice city for tourists, etc. So you have immersed visits, etc. So if you want to attract students and show them a really fancy campus, I think that's a good selling point for universities. Then obviously we can speak about more the infrastructure aspects, like if you have different buildings and trying to have green buildings. I think that's I think the use case are very similar to what would be a neighborhood in some sense.
Thank you so much, and maybe we'll dream on the education of the future and see how the digital twin will play a role for us in the future.
It's time to leave. Thank you all for participating to in this morning session organized by the École des Ponts. In a few hours, you will be able to find the entire conference of the schools on the school's website. Sorry for my English. And a little news: a new best-of video will also be available in the coming day. Have a nice day and see you soon. Sorry.
Sure.
Thank you again.
Thank you very much.